We've got 4 trinomials to factor, and what we want to do is take them and write them as the product of the 2 binomials that we multiplied to get them in the first place. So here I have x squared plus 7x plus 12. If this factors, it's going to factor into the product of 2 binomials. Now I see that my first term is 1x squared, so I know that that's going to come from x times x. What I want to do is put in 2 numbers here that I can multiply and get 12, and then add and get 7. So I see if I put in plus 3 and plus 4, that will work. Now let's check. X times x, x squared. 3 times 4, 12. Inside I have 3x, plus outside I have 4x. They add up to 7x. So this binomial times this binomial does in fact give me x squared plus 7x plus 12. Once you find the factors of a trinomial like this, they're unique. There is no other pair of binomials to multiply and get this. Here's another problem. Want to multiply 2 binomials and end up with a squared plus 10a plus 21. Again, I have 1a squared, so that makes it a little easier. I'm going to have a times a right here. So I need 2 numbers to put here and here to multiply and get 21 and add and get 10. They must be 3 and 7. Inside I have 3a, outside I have 7a. 3a plus 7a is 10a. My last 2 together, 3 times 7 is 21. My first 2, a times a is a squared. So I multiply these back out and see that I get what I started with. Again, what this is good for is changing addition into multiplication. Here's another one. 3a squared minus 3a minus 60. Before I do my factoring as into 2 binomials, I want to take out the greatest common factor. So I'll begin by that kind of factoring. 3 times a squared minus a minus 20. Now that'll be 3 times, I need 2 binomials. Each will start with a because I have a times a to give me a squared. I want to multiply the 2 numbers right here and get negative 20, and then add and get negative a. Must be minus 5 and plus 4. Inside I have minus 5a, outside positive 4a. Those add up to negative 1a. My last term is negative 5 times positive 4, which is negative 20. My first term comes from a times a, which is a squared. So here is the complete factorization for this original polynomial right here. And notice that 3 is one of the factors. The factors are 3, a minus 5, and a plus 4. Here's another one. Let's see. 100p squared minus 1300p plus 4000. Let's begin by taking 100 outside. What's left is p squared minus 13p plus 40. Now we should be able to factor that. 100 times 2 binomials, p there and p there, so that p times p is p squared. Want to multiply and get 40 and add and get minus 13. How about minus 8 and minus 5? Negative 8 times negative 5, positive 40. Negative 8p plus negative 5p add up to negative 13p, and then p times p is p squared. So that's the complete factorization for this polynomial right here. So the first thing you want to do in any kind of factoring is look for the greatest common factor. If there is a greatest common factor other than the number 1, you want to factor it out first and then factor the polynomial that remains.